welcome back. This is lesson 6-6A, the fundamental theorem of algebra. So far, you have learned several important properties about real roots of polynomial equations. In this table, you'll find out that the following statements are equivalent. You already know this, but it's just written a little bit differently in more of the algebra terms. So you know that a real number r is the root of a polynomial equation of the function p of x equals 0. You know that p of r will equal 0. And what that's telling us is that r is an x-intercept of the graph of p of x. So what we're basically saying is when y is 0, what is x? And that tells us where our x-intercept is. We also know that x minus r is a factor of the function p of x. And when you divide the rule for p of x by x minus r, you're going to get the remainder 0. We've been doing that with our synthetic division. And finally, you know that the r is a 0 of the function p of x. Okay, so you can use this information to write polynomial function when given in zeros. Okay, so before we go any further, I want to just talk about a review of factoring. So when we're asked to factor something, the first thing we need to do is go ahead and set it equal to 0. So let's just subtract 17x squared from both sides. And so minus 17x squared. So we end up with x to the 4th minus 17x squared plus 16. And so we know in order to factor this, we can say what two numbers multiply together to get 16, add together to get negative 17. And we know that is negative 16 times negative 1. So my factor is going to be x squared minus 16 times x squared minus 1. Okay, because remember, this is a fourth and a squared here. All right, so we're not finished factoring yet. I can see that this is the difference of two perfect squares. So that's going to be x plus 4 and x minus 4. And this one is also a difference of perfect squares because don't forget, 1 is a perfect square. So that's going to be x plus 1 and x minus 1. All right, and so in the end, if each of these are equal to 0, then I know that x is going to either equal negative 4, x will equal positive 4, x will equal negative 1, or x will equal positive 1. If any of these are true, then the whole statement is true because only one of them has to be 0 and multiplied by the other 3 to get our final answer of 0 and make that true. All right, so now what I want you to just think about in your mind before we go any further is our roots right here. Notice, if we are given the roots, we can easily get ourselves back to our original polynomial. So let's just say if we were given the root x equals negative 4, we realize that that is corresponds to x plus 4. And if we're told x equals 4, we know that corresponds to x minus 4. Okay? And so on. So if I was given just the x minus 1, I could remember that that corresponds to the x plus 1. And if I was told that one of the roots is x equals 1, I would know that corresponds to x minus 1. And then all I would have to do is go back and remultiply again. I would just FOIL this. That would be x squared minus 16. And I could go back and FOIL this set, and that would be x squared minus 1. And then I could put it all the way back and see that that would end up being x to the 4th. So x squared times x squared is x to the 4th minus 1x squared minus 16x squared plus 16, which equals x to the 4th minus 16x squared plus, or I'm sorry, that would be 17. Ooh, okay. 17x squared, whoops, plus 16. And so you can see if we start with our roots, we can just fill them back in, multiply them out, and end up with our original polynomial. So we can go in either direction. So in this example, we're given exactly that problem. So we've been given the roots, and so now we're asked to write the polynomial function if we've been given the roots. So we're going to just do it all backwards. So the first thing we need to do is realize that if r is a 0, it's a root, then x minus r is a factor. So here we have, when I have one of the roots is -1, then that would actually be x minus a -1, which is the same as x plus. Okay, they told me that one of the roots is 2/3, so x minus 2/3. And they tell me one of the roots is 4, so that's going to be x minus 4. Now the next step, I'm not going to do every single step for you, but you need to understand that all we have to do is multiply the first two binomials out. So we would FOIL, okay? And then we would FOIL again. We would, or not FOIL the second time, but we would multiply the next term by this x minus 4. So the second thing we would do is to multiply the trinomial by the binomial. So if I'm given the roots, I can just fill it back in and come up with my original polynomial function. Okay, so I'd like you to try this one on your own. It says write the simplest polynomial function with the given zeros. So we have -2, 2, and 4. So turn your video off for just a second and try this one on your own. Okay, so when you tried this on your own, the very first thing you should have noticed, or you should have done, is gone ahead and set each one up. So if our first term is -2, this would be x minus a -2, which is the same as x plus 2. And then our second one is x minus 2, and our third one is x minus 4. Once we've done that, we just have to multiply. And again, I didn't do all the work for you, but you should actually multiply the first two binomials together, and that the first two, x plus 2 and times x minus 2, we know is x squared minus 4, because that's the difference of two perfect squares. And then we multiply by the third binomial, or multiply the trinomial by the binomial now, and we end up with this equation, x to the third minus 4x squared minus 4x plus 16. So I don't think that's too challenging for you, so go ahead and try one more on your own. All right, so here's one more for you to try on your own. Turn your video off and give it a try. Okay, this one is not too challenging either, just getting your math correct. So the first thing we want to do is go ahead, and if r is a 0 of the function p of x, then x minus r is a factor. So here's my first root, so x minus my root. Here's my second one, and there it is. And here's my third one, here it is. All we have to do now is multiply together the first two binomials together. And then the next time, all we have to do is go back and multiply the trinomial by the binomial. And here is our final answer. So I hope that you were able to get that without any problems. All right, let's notice the degree of the function in example 1, and I just cut and paste it back onto this page, is the same number of zeros. So what does that mean? All right, so notice the degree in this function, p of x, the highest degree is 3. And notice that we had 3 real roots, okay? So this says this is true for all polynomial functions. However, all of the zeros are not necessarily real zeros. So let's remember what we talked about when we were talking about our quadratic equations before. Usually, or not usually, but sometimes, the parabola might cross our x-axis. So there we have our roots here, okay? Sometimes it does not. Remember, we talked about when we had a parabola that's like this, we never actually cross our x-axis. So when y equals 0, we don't actually cross the x-axis here sometimes. Now, what we did learn is that this is our x-axis and this is our imaginary. And so we, when we did our quadratic equation, sometimes we came out with a problem that said x equals plus or minus 1 plus 2i, maybe. Okay, so this would be a complex number using an imaginary number. It's not a real number, but it is a complex number. And so this is true for all polynomial functions. that if whatever your highest exponent is the number of roots. However, all the zeros are not necessarily real zeros. Polynomial functions, like quadratic functions, may have complex zeros that are not real numbers. So sometimes we're going to have some of the roots that are real numbers, and other times they're not, and we're going to have to learn how to find all of them. So the fundamental theorem of algebra says every polynomial function of a degree greater than 1, so here our degree was 3, has at least one zero, where a zero may be a complex number. All right, so when we work it out, we may not have any whole numbers. It might be a complex number. And then the corollary says that every polynomial function of a degree n, which is greater than 1, again, here we have our exponent, has exactly n zeros, including multiplicity. So if I have an exponent of a 3, I'm going to have at least 3 roots. Now, they might not all be real roots, but I will have 3 roots. So with that in mind, using this theorem, we can write any polynomial function in factor form. To find all the roots of a polynomial equation, you can use a combination of the rational root theorem, the irrational root theorem, and methods for finding complex roots such as the quadratic formula. Remember, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So buckle your seatbelts. We got a lot of work to do. All right, so let's try this example together. We're going to solve this equation by finding all of the roots. So the first thing that we want to do is go ahead and realize that the polynomial is of a 4th degree. Okay, so that tells us there are exactly 4 roots of the equation, so we're going to have to find 4 of them. All right, the next step that we're going to do, or step 1, is we're going to use the rational root theorem to identify the rational roots. Now remember what the rational root theorem said. It said take this last constant, and we're going to look at all the factors of negative 36, and we're going to divide it by all of the factors of 1, fortunately. So in our case, all we're going to have to do is find all of the factors of 36, which are right here. And so that was our P was our negative 36, and our Q was 1. And so here's all the factors. So we know something in here is going to be helpful. All right, so here's our equation, 1, 3, 5, 27, 36. So we're going to move on and take a look at this. So the first thing we want to do is go ahead and put this equation in your calculator. All right, and this is really helpful. So when we put this in our calculator, we can see that it looks like there's a real root at 1 and a real root at 4. 1, 2, 3, 4, yes. Okay, so real root at negative 1 and a real root at 4. Now remember, we were looking for all the factors of negative 36, and plus or minus 1 and 4 are both in that group. So the first thing we want to do is go ahead and try using our synthetic division to see if indeed, if that's the truth, negative 1 and 4 are factors. So I'm going to set that up for us. So we're going to test for the possible real roots first, because that's where it crossed actually the x-axis. So when we do that, let's test for x equals the negative 1. So that would be x plus 1 as a factor. So let's set up our synthetic division. And remember, the very first thing we do in synthetic division is we bring our 1 straight down. All right, so let's go for that. So there it is. So negative 1 times 1 is negative 1. Add those together, we get negative 4. Multiplied by negative 1, we get positive 4. Add those together, we get 9. Negative 1 times 9 is negative 9. Add those together, we get negative 36. Negative 1 times negative 36 is positive 36 with a 0 remainder. So we know that this is actually a factor. It looked like it would be on the graph, and sure enough it is. Okay, so remember what we have here, we started out with x to the 4th. So when we divide, we actually have x to the 3rd, x squared, x minus 36. So this is still kind of hard for us to factor simply yet. So remember that our other point was at x equals 4. So let's test that too. Okay, so here, so far we know that x plus 1 is a factor. let's test with x when x was 4. So let's test that. So let's go ahead and set up our synthetic division. This time, notice I'm using the factored part of our equation. So the 1, 4, negative 4, 9, and negative 36. So let's try our 4. So again, we bring our 1 straight down and then start multiplying. 4 times 1 is 4. Add negative 4 plus 4 is 0. 4 times 0 is 0. 0 plus 9 is 9. And 4 plus 9 is a positive 36. Add those together, we get 0. So we have just proved that x minus 4 is indeed also a factor of our original polynomial. Now, that's 2 factors that we have so far. But our equation told us from the very beginning that we were going to have 4. So let's look at this. This is x squared now plus 0x plus 9. So we have x squared plus 9. Okay, so when we look at that, we don't have any easy ways of factoring that now because as far as we're concerned, that's basically finished. But we can use our quadratic equation to find exactly the other 2. So let's take a look at that. So here's our x squared plus 9. Here's our x squared plus 9. Sorry, my phone went off. And so now what we're going to have to do is solve x squared plus 9 equals 0 to find the remaining roots. All right, so when we do that, we actually don't have to use the quadratic equation on this one. We can just go ahead and set that equal to 0. And you can see if you subtract your 9 from both sides, so x is going to equal plus or minus 3i. And if you're not sure how that happened, x squared equals negative 9. So if we square both sides, we end up getting x equals negative 3, actually plus or minus 3i, because that negative in here made it a I. Okay, so there we have all of our roots now. Let's take a look at it. So the fully factored form of the equation is going to be x plus 1, x minus 4, x plus 3i, and x minus 3i, and all of those equal 0. So there are our solutions right there. Okay, let's go ahead and try one on your own now. Turn the video off and see if you can find this on your own. So give it a try. Okay, I know that probably took you a little bit of a while, so let's go through it and see if you can figure if you got it right. So the first thing we want to notice is how many roots are we actually looking for. And so when we look at this, we can see that our highest exponent is 4. So that we are going to actually be looking for exactly 4 roots of the equation. So our step 1 is we're going to use the rational root theorem to identify rational roots. So luckily, we only have a 1 there, so all we have to do is find our factors of negative 20. Okay, so those are going to actually be plus or minus 1, 2, 4, 5, and 10. Okay, so this is our pile that we're looking at. All right, so next what you want to do is go ahead and put it in your calculator and graph it and see what that looks like. So when you put it in your calculator, we see that it looks like 1, 2, 3, 4, 5. Okay, so it looks like it's hitting at negative 5. And negative 5 was one of our factors of 20. Okay, we also see one at positive 1. So the very first thing we want to do is verify if negative 5 and 1 are truly factors of this polynomial. So we're going to do our synthetic division to check and find that out. So let's test it. Let's go ahead and test for negative 5. So we want to see if the remainder is going to be 0. So here we go. Remember, the very first thing in our synthetic division is bring your 1 straight down. So negative 5 times 1 is negative 5. Add those together, and we get negative 1. Negative 5 times negative 1 is positive 5. Add them together, we get 4. Negative 5 times 4 is 20. Negative 20 plus 16 is negative 4. Negative 4 times negative 5 is positive 20, and we get a 0 as a remainder. So it tells us that x plus 5 is a factor. All right, now we need to check our other one, and that was a positive 1. So we're going to test positive 1 by using our synthetic division again. Notice this time we're using the smaller amount that we found in the last section by dividing by 1, or I'm sorry, by 5. So again, the very first thing we want to do is bring our 1 straight down. 1 times 1 is 1. Negative 1 plus 1 is 0. 1 times 0 is 0. 4 plus 0 is 4. And 1 times 4 is 4. And that gives us a 0. So we end up, once again, with 1, 0, and 4. And we find that x minus 1 is indeed a factor. Yay. So now we have 2 of them. Now remember, this is now x squared plus 0x plus 4. So we have x squared plus 4. All right, so you should know what to do by now with this. And so all we have to do, here's our x squared plus 4, is we have to solve for x squared plus 4. So all we did here, x squared equals, let's see, we're going to move our 4 over there, negative 4. So we square both sides, and we get x equals plus or minus 2i, which is what they got there. Okay, so here we go. The fully factored form of the equation is going to be x plus 5, x minus 1, x plus 2i, and x minus 2i. So we have 1, 2, 3, 4, exactly what we needed. And here are solutions 1, 2, 3, 4. So when your highest exponent is 4, you need to make sure that you have 4 solutions. Okay, so before we go any further, I just want to have you recall the irrational root theorem. And the irrational root theorem, remember, says that if we have one root that is a plus b to the square root of c is a root, then a minus b to the square root of c is also a root. And so if that happens to be an imaginary number in there, it's also going to be the conjugate is what those are called, the a plus b square root of c and a minus b square root of c. So we're going to need that for our next problem. All right, so we're going to try this next example. It says we're going to be writing a polynomial function with the complex zeros. So they're not all the real number zeros, but just the complex and real. So the question says write the simplest function with zeros at 2 plus I, square root of 3, and 1. So let's remember what I just talked about with our rule. Here I have a 2 plus I. So that rule tells us, our irrational root theorem tells us that 2 minus I is also going to be a root. And if square root of 3 is a root, the negative square root of a 3 is also a root. So actually we're going to have 1, 2, 3, 4, 5 roots. So our problem is going to have the highest exponent is going to be 5. And here it is written out a little cleaner for you. By the rational root theorem and the complex conjugate root theorem, the irrational roots and complex come in conjugate pairs, okay? So there are 5 roots, 2 plus I, 2 minus I, square root of 3, negative square root of 3, and 1. So the polynomial is going to have a degree of 5, x to the 5th power. All right, so let's get started. All right, so now that we know what our roots are, we need to write the equation in factored form. So what we're going to do is just go ahead and take a look at this and notice that it's x minus our root, x minus the root, x minus the root, and there it is, x minus the root. All right, and now what we need to do is the hard part. What we need to do now is go ahead and multiply each of these together. It gets kind of long, so you have to be really careful with what you're doing. All right, so what we're going to do first is let's go ahead and take our first 2 pieces and multiply those together. Now this is kind of difficult when we're multiplying, so what I'm going to do, instead of actually at first multiplying the 2 plus I, is I'm going to label the 2 plus I as A and the 2 minus I as B, so we can kind of see what exactly we need to do on this, because it gets kind of confusing with all the negatives and the minuses and everything. So let's rewrite this so we can see it a little better. So what we're going to do is say x minus A times x minus b. Okay, so when we do that, we get x squared, I'll write it over here, minus bx minus ax plus ab. So I just FOILed that, and that's how I got all of that. All right, so what I want to do now is go ahead and I want to figure out what b times x is. So that's going to be x times b, and, oops, sorry, I'm going to solve for bx. So that's going to be x times our b, and our b we said was 2 minus I. All right, so we're going to distribute that x, and so x times 2 is 2x, and x minus times I, negative I, is going to be minus ix. All right, and then we have our ax, so let's go ahead and figure out what ax is. And that's going to be x times our a, which is 2 plus I. So when we distribute that, x times 2 is 2x plus I times x. All right. Now let's go ahead and figure out what our AB is. AB equals 2 plus I times 2 minus I. And we can just FOIL this. That's going to be 4 minus 2I plus 2I minus I squared. All right? And so now that we know that, we can see that that is going to equal 4 minus 2I plus 2I is 0. And notice that we have I squared. Remember, I squared is going to be minus. I squared, remember, is equal to negative 1. So 4 minus a negative 1, so that's plus a positive, so that's going to equal 5. All right, so let's go ahead and rewrite what we have then. This should be x squared minus bx, which is 2x minus 1x, minus ax, which is 2x plus 1x, and then minus AB, which is, or plus AB, sorry, plus 5, okay, because we decided AB was 5. All right, so let's get all our subtraction in correctly. When we subtract, this changes all of our signs. And so I see that I have an x squared. Negative 2x plus negative 2x is negative 4x. All right, and then positive ix plus a negative ix is 0 plus 5. Okay, so my first piece is going to be x squared minus 4x plus 5. All right, the next piece I want to multiply together is going to be this, the x minus square root of 3 times x plus square root of 3. And all we have to do is FOIL that. So x times x is x squared plus square root of 3 times x minus square root of 3 times x minus 3. So we end up with x squared, this turns to 0, minus 3. So there's our second part right here. And then our third part is just going to be the x minus 1. All right, so what we need to do is just put them all together, and we're going to have to multiply them. I'm going to do that on the next page, but I'll go ahead and write that out. Kind of got in the way there. Let's see if I can clean this up here a little bit. Okay, so you can see that when we multiply all those pieces together, we have our x squared minus 4x plus 5 right here, and then our x squared minus 3 right here, and x minus 1 right there. All right, so next we have to do is start multiplying. So we're going to multiply those together now. All right. And when you multiply them together, we end up with this equation, and finally we'll end up, once we multiply all these together with each other, we end up with the final product. And notice that we had 5 roots, and our exponent, our leading exponent, is also a 5. Okay, here's one for you to try on your own. Write the simplest function with zeros of 2i, I plus square root of 2, and 3. All right, so I want you to go really, really slow and be really careful with this because it's so easy to make mistakes. So go ahead and turn your video off and give it a try. And then when you're ready or you think you've gone as far as you can, turn your video back on and we'll do it together. Okay, so the first thing we want to do is remember our complex conjugate root theorem. All right, so when we look at this, we see that we have a 2i. Okay, now that's a complex, so one of our roots is 0, so one of them is going to be 2i, but you have to remember we have another one that's going to be minus 2i. And here we have 1 plus square root of 2, so we have to remember that 1 minus square root of 2 is also going to be 1. So in the end, we're going to have 1, 2, 3, 4, 5 zeros, which tells us that we're going to end up, our highest exponent is going to be x to the 5th on the function that we write. So here it is written out a little bit more carefully for you. Identify all of the roots. So by the rational root theorem and the complex root theorem, the irrational roots and complex roots come in conjugate pairs. Okay, that means one's plus and one minus. There are 5 roots, 2i, negative 2i, 1 plus square root, and 1 minus the square root of 2 and 3. So the polynomial must have 5 degrees. So now we have to remember how are we going to write all of those. So we're going to have to say x minus all of that, x minus 2i, x minus a negative 2i, x minus 1 plus square root of 2, x minus square root of 2, and finally x minus 3. So you can see that it's going to be pretty complicated, a lot of multiplying, so we're going to just take it really, really slow. Okay, so first of all, we got to write the equation in factored form, which we just did, and here it is rewritten for us again. So now we have to start out with our multiplying. Okay, so we're going to go really slow. So let's multiply our first group. I'm going to do that in red. Okay, so we'll multiply our first group. So let's go ahead and do that. I'm going to do it up here. X minus 2i times x plus 2i. All right, so when we FOIL that, we get x squared plus 2ix minus 2ix minus 4i squared. Okay, so our 2ix and minus 2ix add together to 0, so we end up with x squared. So let's look at our minus 4 times an I squared. Remember, I squared is negative 1. Okay, so we have a negative 4 times negative 1, which is a positive 4. So here's our first piece that we're going to have to multiply together. Okay, the next one we're going to multiply together is this group, and this is the more complicated group. Okay, so I'm going to call this piece A and this piece B. All right, so just to keep it a little bit less complicated. So first of all, I'm going to write what my pattern is going to be. It's going to be x minus A times x minus B. So when I FOIL that out, I get x squared minus bx minus ax plus ab. All right, so first of all, I'm going to go ahead and figure out what my bx is. So I'm going to say bx is equal to x times b, and b was 1 minus the square root of 2. When I distribute my x to both of them, I get x minus square root of 2 times x. All right, my ax is going to be x times the a, and our a was 1 plus square root of 2. So that's going to, when I distribute that, I'm going to get x plus square root of 2x. And then a times b is equal to 1 plus square root of 2, that's our a, times 1 minus square root of 2. So when I distribute that, 1 times 1 is 1, let's see, minus square root of 2 plus square root of 2 minus 2, because square root of 2 times square root of 2 is 2, and it's a positive times a negative, so that's a negative. So minus square root of 2 plus square root of 2 equals 0. So I end up with 1 minus 2 is actually negative 1. Okay, so now let's fill them back all into our original formula here. So it says x squared minus bx, and bx we see right here is going to be x minus 2x, and then it says minus ax, and so here's my ax, and that's going to be x plus square root of 2x. Sorry, I left that square root off on that one. And then plus ab, so that's going to be, let's see, plus a negative 1. All right, so with all of that written out, I have to be really careful with my negatives here and my minuses. So this says minus. That means actually plus, and we're going to change the signs of both of these. And so we're going to change this and change the signs of both the x and that. Okay, so now we see that positive 2x plus a negative 2x is 0, and we have a negative 1x squared and a negative 1x squared. So that's 2x squared. So what I have here is going to be x squared plus 2x squared minus 1. So that is our next part. And our last part is just simply x minus 3. Okay, so I have to multiply all three of these parts together. So I'm going to have to take my x squared plus 4. Let me do it this way, sorry. I'm going to take my x squared plus 4, and I'm going to have to multiply that by the x squared plus 2x minus 1, and then I'm going to have to multiply all that by my x minus 3. Okay, so let's do that on the next slide. All right, so here I have rewritten all this out, so let's multiply them out together. Let's go ahead and start out with our x squared plus 4, and we're going to multiply that by x squared minus 2x minus 1. All right, so let's multiply all of that. So I'm just going to distribute. X squared times x squared is x to the 4th, okay? X squared minus times negative 2x is minus 2x to the 3rd, and x squared plus a negative 1 is going to be minus 1x squared. Okay, now I'm going to multiply my 4. 4 times x squared is going to be positive 4x squared, and notice I just put it right under my other x squared. So 4 times negative 2 is going to be negative 8x, and then 4 times a negative 1 is plus a negative 4. Okay, we're going to add all that together, and let's see. So x to the 4th, we're going to bring that straight down. X to the 4th minus 2x to the 3rd plus 3x squared minus 8x minus 4. So we're going to take that whole piece, and now we have to multiply it by x minus 3. All right, so now we're going to distribute this x to everything. So we're going to end up with x to the 5th. X times negative 2 is negative 2. X to the 4th. Okay, and then plus 3x to the 3rd minus 8x squared minus 4x. Now I have to distribute my negative 3 to everything. Negative 3 times x to the 4th is negative 3x to the 4th. Negative 3 times negative 2 is plus 6x to the 3rd. Negative 3 times 3 is minus 9x squared plus 24x plus 12. Okay, well, let's add all of that together. And it's x to the 5th minus 5x to the 4th plus 9x third minus 17x squared plus 20x plus 12. And if you got that, give yourself a pat on the back. That's a really, really long problem. And notice that my highest degree is indeed x to the 5th, and that's what we said it should be back at the very beginning of the problem. So let's just confirm. X to the 5th minus 5x to the 4th plus 9x to the 3rd minus 17x squared plus 20x plus 12. So I hope that you got that right. Okay, that's the end of this lesson. Thanks for working really hard on this. Have a great day. See you soon. Bye.